Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about Wheatstone bridge consists of a rectangle formed by resistors or capacitors, whose opposite ends are connected, one to a constant voltage source and the other to a galvanometer. When by varying a resistance, which is the one in contact with the process, the galvanometer detects zero current and it is said that the bridge is balanced. The Wheatstone bridge is arranged in 2, 3, or 4 wire systems, depending on the connection wires of the bridge resistance probe. In the 2-wire system, the resistance probe is connected to one of the arms of the bridge, and R3 is varied until the galvanometer deviation is cancelled. At that time, this equation is fulfilled, and from here, X is deduced as the value of the resistance probe. The 2-wire assembly is the simplest, but it has the disadvantage that the resistance of the wires A and B connecting the probe to the bridge varies when the temperature changes, and this variation distorts the indication. Although these wires are of low resistance, the lengths that may exist in the field between the probe and the panel where the receiving instrument is add some resistance to the probe arm. Then the previous equation becomes this other one. The 2-wire systems are used with moderate connecting wire resistances, and when the reading does not need to be too accurate. In the 3-wire system, the probe is connected by 3 wires to the bridge. Thus, the measurement is not affected by the length of the conductors or by the temperature, since this simultaneously influences 2 adjacent arms of the bridge. The only condition being that the resistance of the wires A and B is exactly the same. In the corresponding equations, since Ka and Kb are equal, making R2 by R1 equal to 1, R3 can be set to a value equal to X, so that the galvanometer does not indicate stress. The 4-wire assembly is used to obtain the highest possible precision in measurement, as is the case with digital temperature converters or the calibration of resistance standards in the laboratory. 2 measurements of probe resistance are made in the laboratory by combining the connections so that the probe passes from one arm of the bridge to the adjacent arm. Thus, the uneven resistances of the connecting wires are compensated, and the resistance value is equal to the average of the values determined in the 2 measurements. Classical automatic measurement of resistance, and therefore temperature, is carried out by self-balancing instruments using a Wheatstone bridge circuit. The resistance probe is connected to the bridge by 3 wires. If the bridge is unbalanced, the error signal in the form of direct voltage that appears in the image as AA is converted to an alternating voltage, VB, and amplified in voltage CC and power DD to excite the balance motor E. This moves in the suitable direction to balance the bridge through the mobile arm of the rheostat, which at the same time actuates the indication, register, and control mechanisms. Another way to measure temperature automatically is through a capacity bridge, which uses a variable capacitor whose position is calibrated according to the temperature, fitting the circuit with the stabilized alternating voltage of an oscillator. It is similar to the Wheatstone bridge in that, in the event of an error signal, the amplifier feeds the balance motor that drives the variable capacitor. Adding a converter or transducer with data transmission via bus to the resistance probe allows 1. To obtain an intelligent transmitter with the possibility of automatic change of the sensor or the measuring field, obtaining Wheatstone or capacity bridges of different characteristics by hardware or software, etc. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adios! My baby don't mess around.